Hello everyone. In this video we will learn about the set theory. Set theory means we will learn about the sets. What is a set? A set actually is a well-defined collection of objects. What is the meaning of well-defined? If we understand the meaning of well-defined, we can understand the set. Well-defined means if we are collecting the objects which can be recognized by a particular common property, then we call it a well-defined collection. For example, in the daily life, you find these shops around you. These are also some sort of sets. Like if you want to purchase some item related to stationery, some notebook or some book or some pen, you will certainly go to a stationery shop, because you know that all the items which are related to stationery will be available in that. Suppose you want to purchase some ready-made garments, a t-shirt, a jeans, you will certainly go to the ready-made garment shop. You will not go to a cloth shop, because in cloth shop you will get the unstitched clothes. If you want to purchase a pair of shoes, you will not go to a sweet seller. Will you? No, you will go to a shoe mart where you will get the shoes. It means all these shops can also be said to be sets. So here we are understanding the meaning of well-defined now. Suppose we have some examples here. The first example is a collection of vowels in English alphabet. Only vowels, and that too of English alphabets, will be in that particular collection. So they have a common property that they are the vowels of English alphabets. Second, we have a collection of squares of natural numbers. Here 1, 4, 9, these are the squares of natural numbers will be collected. 5 will not come there because that is not a square of natural number. It means all the numbers which have been collected in this group, they will be the squares of some natural number. Third is a collection of all students of class 11th of a school. Here we find that in this particular collection, the common property is that all the students or all the boys or all the girls which have been taken in that group are the students of class 11 of a particular school. They can't be from any other class. They also have this particular common property. And hence these all can be represented as sets. They are well-defined collections. Now some more we discuss here, like a collection of handsome boys of a class. Who you can say a handsome boy? You don't have any of the meter to measure the handsomeness. Handsome boys actually comes by comparison. We compare the boys and then we say this is handsome. And that is why it is not a well-defined collection. Next is a collection of poor people of a village. Poor. Poverty we define or we understand by richness or poorness. The person who is having more income, we say he is rich. And the person who is having less income, he is poor. Suppose a person is earning 1000 rupees a month and another is earning 5000 rupees a month. Then this person who is earning 1000 is poor about this person who is earning 5000. But when you compare the second person with a person who is earning 50,000 rupees a month, then he is poor about that. So until unless a limit is not defined for this, we cannot say that this is a common property or this can be represented as a set. This is not well defined. The next is a collection of 5 good fruits. If you ask the people about the good fruits, everyone will have a choice of their own good fruits. And that is why there comes the comparison. So wherever we find that the comparison is taken as the base of collection, that is not well defined. We say they are not sets. Now the members of the objects which are collected in a set They are known as the elements of set. After learning about the definition of set, about the collections which can be represented as set, let's learn about the representation of a set. A set, when we represent this, can be represented in two different ways. We can say two different forms. The first form we have here is known as a roster form. It is also known as tabular form. And sometimes we also call it as listing form. Because in this we are representing the elements in the form of a table or a list. What we have to learn in this? See, anytime we are representing any of the set in the roster form, we have to remember 3 points. Number one is we have to use only a curly bracket, or we call it braces. That is this. This is the only bracket we have to use for representing a set. The second one is that every element, as I have told you, that members collected or objects collected are known as the elements. All the elements will be separated by a comma. So we have to apply comma between all the elements so that we can separate them. Comma is generally used to understand this. Suppose we have a set having the elements 1, 2, 3 and 4 and we don't put comma, then we will read it as 1234. There is only one element. Whereas if we write it like this 1, 2, 3, 4 having comma between them, now we can say they are 1, 2, 3 and 4. There are 4 elements in it. So this thing we have to remember, that the elements are to be separated by a comma. So this is wrong notation and this is the correct notation or correct representation of set. The third point we have to remember is elements are not to be repeated. No repetition. Like suppose we want to represent a set of all the letters of the word mathematics. A set of all letters of word mathematics. In this what we will see, we will write this as curly bracket first. The first element here is M, second is A, next is T, next is H, next is E. Now M has already come here, so this will not be written second time. Then A has already also come. T also has come. Then I, C and S. So this is the way we have to see that the elements are not to be repeated. Suppose we want to write another set, a set containing the vowels of English alphabets. Then we will write this as A, E, I, O, U. Please remember these 3 points and then you will have a perfect representation of a set in the roster form or tabular form or listing form. Generally we write the names of the sets with the capital letters, like we can write this as set A, this we can write as set B. Now the second form of the representation of a set is known as set builder form. Let's learn that now. Set builder form is also known as rule form. Actually what we do in this, we are representing the elements with the help of some variables like x, y, etc. And then we write the rule or the property of the elements by which they are representing themselves in the set. Like we have a set of all natural numbers less than 6. In the set builder form, we will write this suppose as set A, and we can write X such that, this is the symbol for such that. What X? X is a natural number and that is less than 6. So we can write X is a natural number and X is less than 6. If we want to represent the same in the roster form, we can write this as A equal to 1, 2, 3, 4, 5. All these natural numbers are less than 6. So they will be collected in this particular set. Second is, suppose we have one more example, that is a set of vowels of English alphabets, as we have taken the second example in the roster form also. A set of vowels of English alphabets. Suppose we write this as set B. Here we will write it as X such that X is a vowel of English alphabets. The next example, we can take a set of odd natural numbers. Suppose we write this as set C. We can write it as X such that, we can represent such that as this or a vertical line, such that X is an odd natural number. Or we can also represent this as X such that X is equal to 2n plus 1, where n is a natural number. This is the way we can represent the set in the set builder form. Now we will be learning about the representation of elements of a set. So we have learned that the objects or the members contained in a set are known as its elements. How to represent the elements of a set? See, suppose we have a set A containing the elements 1, 2, 4, 5, 7, 8. And we want to represent that 2 is an element of set A. 2 is an element of set A. We can also say that 2 belongs to set A. Or we can also say that 2 is contained in A. The symbolic representation for this is 2 belongs to A. This is the symbol which we are using, that is known as epsilon. It's a Greek letter which we are using for representing the element of a set. Now suppose we want to say 6 is belonging to A. Is it? No. 6 is not belonging to A. 6 is not contained in A. 6 is not an element of A. So we write 6 is not an element of set A. We represent this as 6 is not belonging to A or is not an element of A. We cut it by a line like we cut equal to show not equal to. Suppose we have some more example. Suppose we want to say that 1 is an element of A or not. So the symbol used will be 1 is an element of A because 1 is contained in this. 3 is belonging to A or not. Let's see, 3 is not the element of set A. So we will write the symbol not an element of set A. So in this video we learnt about the set, representation of a set, forms of representation of set, and representation of an element of a set. In the next video we will learn about some special sets and types of sets. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.